guys, my name is Liad. Today I'm going to talk about a data structure called stack. A stack is also a linear data structure. So what is a stack? A stack is a linear data structure which follows a particular order in which the operations are performed. The order may be LIFO, that means last in first out, or FILO, which means first in last out. For example, you can see a stack of books in the background. If you want to place a book, you have to place it top of all the books, right? And if you want to remove a book, you have to remove from the top of all the books. That means the top books you have to remove. If you want to remove a book from any internal position, suppose this book, so firstly you have to remove all of the top books of this book, so then you can remove this book. So this is exactly the stack data structure. In this data structure, if you push some values, the value you will the value you will push before, it will be to the closer to the bottom, and the value you will push later, it will be closer to the top. Okay, so the value you will push later, or you will push at the last, it will be at the top of the stack. The value you will push first, it will be at the bottom. So then the last value we will push, it will be removed first, and the first value you will push, it will be removed last, right? So this is the stack data structure. So the applications of a stack are these. First of all, expression handling, we will discuss this later. Backtracking and function call and return process. The function call and return process also use a stack data structure. Whenever we call a function, it goes into the stack of memory, right? And the function we call first, it will return at the last, and the function we call last, it will return at the first if we do some recursion function, right? Functions and operations that we will do in this video. So first of all, we will make is empty functions, size function, and top functions, and we will also do some operations like push and pop. Okay, so we will implement this data structure stack by using linked list. So first of all, see the push operation. So we will do this by actually using singly linked list. So push operation means we will push it at the top of the stack, right? That means we will insert the value at the beginning of this singly linked list. So suppose this singly linked list contains three nodes, node A, node B, node C. We want to push this node D, so we have to insert this at the beginning of this singly linked list. So for this we have to give the address of the first node A to the next pointer of the new node D, right? Then we have to change the direction of head to the pointing to the new node. In this way we can do push operation. So then let's see the pop operation. Pop means we have to remove a value from the top of the stack, right? So for that we have to delete a node from the beginning. Suppose this node A at the beginning, we have to remove this node. So for that, simply we have to change the direction of head to pointing to the node B, which is the second node, and then we have to delete the node A, right? In this way we can do pop operations. So now let's see the code of stack. So this is the code. First of all, we have made a node class. We have made all the members public. First of all, we need a data, integer data, and then a next pointer. I have initialized data of node with value 0, and next pointer will to be null if the object of node class type is declared without any value, right? So if you declared some object of node class with a value, then I have initialized the data with this value and the next pointer with this null. So we can, it is called actually member initializer list in C++. We can do this initialization by this member initializer list. You can do making the constructor inside the function. You can do, suppose in this way, you can do this in this way inside the function. You can do data equals 0 and next equals null inside this function in this way. You can do any of these two ways, but this is the better way. Member initializer list, this is the better way. We will do in this way. Then I have made a stack class. First of all, declares all the members public, then declare a node pointer to be head, and then also we need a length of the stack, right? So then we first of all we have made a stack constructor. In this way we can initialize also. We have seen that we have initialized head to be null and length to be 0. By default it will be initialized with this value. Then I have made three functions, right? I have isEmpty function, size function, and top function. So this will return value. So first of all, is empty. That means the stack is empty or not. If the stack is empty, then it will return true. Otherwise, it will return false. It is a boolean type function. So the stack is empty. The stack will be empty when the head will be null, right? So if the head is null, then it will return true. Otherwise, it will return false. Then the size function, it will simply return the length of the stack. Then the top function, first we have to return the top value of the stack. First of all, we have to check that the stack is empty or not. For that I have called the isEmpty function. If this is empty, then we will say that invalid access because there is no top value. Then I will return -1. But if this is not happened, then we will simply return the data of head, which is the first node in this single image, right? It will be the top value of the stack. Then we will do two types of operations. First of all, push operation and then pop operation. Let's see the push operations. Push means we have to push a value at the top of the stack, right? So this is the value we need in the parameter list. We have created a new node with this value to the member initializer list constructor. Okay, so if we push a value, then the length will be incremented by 1, right? So then I will check that if the head is null or not. That means the stack is empty or not. If the stack is empty or single linked list is empty, then I will simply make the head pointer to be pointing to the new node, and then I will return. If this is not happened, then uh, I have to do some operations. Um, suppose head is pointing to the first node, and the next pointer of the first node is pointing to the second node, and then the next pointer of the second node is pointing to null, right? Then I have to insert this new node at the beginning, right? So beginning means before the first node. So for that, first of all, i have to I have to point the next pointer of the new node to be head, right? That means the first node. So the new node will be here. So it will be pointing to the first node. The next pointer of the node will point to the first node. So for that, we have to give the address of the first node, right? So it will be inside the head, right? Because first of all, head is pointing to the first node. So then we have to change the direction of head to be pointing to the new node. Then I will simply give the address, which is new node, to the point to the head. Okay, then see the pop operation. So pop means we have to pop a value or delete a value from the top of the stack. So it means we have to delete a value from the single linked list, which is from the beginning of the single linked list. So first of all, we have to check that if the head is null or not. If the head is null, then it means that single linked list is already empty, so you have to do nothing. We will simply return. Then if the single linked list is not empty, then we have to pop this value or delete this value, delete this node. So for that, we will store the node firstly, which is the first node. It will be inside the head. Then I have to point the next pointer of the head to be to the next node, right? I have done this. Then I will delete the node simply. Then if we pop a value, then the length will be decremented by 1, right? So inside the main function I have declared a object of stack class. Then I have done some operations. Let's see the operations. For that, first of all, let's run the code. You can see there is no error, and here is the output. So first of all, I have printed the size of the stack. Firstly, it will be 0, right? Because I have pushed no value, so this is 0. Then I have pushed a value 4. I have printed the top value, it will be 4, right? So it will be 4. So top value will be 4. I have pushed 4. Then I have pushed again 6. Then the top value, what will be the top value? So I have pushed 6. Then it will be at the top, right? It will be before 6, before 4. So it will be the top value. Then I have pushed 9. So it will be at the top, right? Then I have pushed 14. 14 will be at the top. Then 34. 34 will be at the top. So then I have printed the size. So it is, you can see, 1 2 3 4 5. So it is size 5, right? So it is correct. Then I have popped a value. So 34, which is at the top, it will be popped. Then I have popped again, so 14 at the top, it will be popped. Then I have printed the top value, so it will be 9 in this case, right? So it is 9, it is correct. So then I have popped a value again, so 9 will be popped. Then I popped again, then 6 will be popped. Then I have printed the size of the stack is 1 in this case, so this is 1. Then I have printed the top value, it is 4, right? It is 4. Then I have popped again, so 4 will be popped, the only single value. Then I have printed that if the if the stack is empty or not. So if this is empty, it will return 1, or otherwise it will return 0, and that means false. So stack is currently empty, right? So it will return 1. So this is 1. Then I have printed the top value, so there is no value in the stack, right? So there will be no top. So in this case I have printed, you can see, invalid access return -1. So this is invalid access -1. So this is all correct, right? So this was all for today. Till the next video drops, keep enjoying, keep practicing, and thank you for watching.